Hi guys, so we are doing lesson 14.1, scatter plots and association. We are working on graphing points. If you don't remember how to graph points, if you're going, oh no, how am I supposed to be graphing this stuff? You can go over to, I have one of my folders is called Math Review, and in there I actually have up for how to graph points, and you can go watch that one. That one goes a lot more in depth to it than what I'm going to be doing today. Okay. So what a scatter plot is, when we graph, remember how typically we would graph and we would have a straight line, and you were given the equation y equals mx plus b. So you were given something that looked like this. Y equals 4x plus 3. And then you were asked to take that and put it on the graph and make the line for it, right? So you were given an equation for it. Scatter plots are a little like that, but not a ton. So a scatter plot, you are given information. Individual points. And graph them. I suppose you could write UR before the given information. Okay, so that's what makes it a scatter plot. So as opposed to our nice line that we ended up with here, a scatter plot tends to look something like this. Okay, you see how it's scattered all over the place? That's why it is a scatter plot. So this is the kind of thing that we use when we do a test of something. So you're doing a scientific study. Let's say that, the drugs that they're trying out for fighting the coronavirus. They give it to people, and then they take the information on how they respond to the drug. How well do they respond? How much of the drug do they give them? That sort of thing. So in that case, they would have a graph, something like this. And over here would be how well. No, sorry. How well would probably be here. So how well they respond, and then over here would be how much they were given. So if they were given 1, 2, 3, 4, 5, and then each individual person that they had would have been given a certain amount. So probably be number of days it took them to get better, something like that. So 1, 2, 3, 4, 5, 6, 7, 8. And we can say that you were given, one person was given 1 ounce and it took them 5 days. Another person was given 2 ounces and it took them 4 days. Another person was given 6 ounces and it took them 4 days. So they can sit there and they can go, oh, wait a second, 2 ounces and 6 ounces, there's absolutely no difference between the two. That's where the scatter plot helps you out. So if I was at 1 and 1, 2, 3, 4, 5, that would be the first point. 2, 4, 3, 4, 5, 6, 4. See how that doesn't make a line? It's just kind of there. This is what we do with a scatter plot. Now, we can use these dots. I can give you where it is right now. It's not super useful, okay? But I can do things with this. I can find a way to do it. So we can look for things like clusters. So a cluster is a lot of points together. So a cluster ends up looking like this. Okay, that's a cluster. You see how all those points are almost right on top of each other? So if this was a scientific experiment that we were doing, we would sit here and we would say, okay, so that's about where everybody ended up. That's kind of where we got what we wanted. But invariably, when you are doing something scientific, you end up with things called outliers. And that is a point. I think in this case, it's only going to be 1 point. My older daughter in high school, they, in their outliers, sometimes ended up with 2 or even 3 points as outliers. But I think currently we're only working with 1 point at this level. A point that doesn't go with the rest. So on this graph that we have all that stuff up there. But what if somebody was over here? They're out in La La Land. Everybody else is having a party and they're just off doing their own thing. That is your outlier. The one who is off doing their own thing is the outlier. A point that doesn't go with the rest, a point that has nothing to do with what anybody else is doing. That is your outlier. Let's get to the second part of our title, association. So what does association mean? Well, do you remember what associate means? To associate means to talk with, to make friends with, to get along with. You associate with people. So in this one, we're talking about how it's related to each other, how it's talking to each other, how it's interacting with each other, how the points relate to each other. There are 3 choices. First choice is when the points seem to generally be going up. See that? How the points are kind of generally going up. That is a positive association. So the more of it we have, the more of it we're going to get, generally speaking, okay? The more that I have, the more that I'm going to get. It's a positive association. However, you don't always have positive associations. Sometimes, the more you have, the less you get. That is a negative association. And sometimes you end up with this and get really, really frustrated. Because that has no association. It's not kind of going up, it's not kind of going down, it's nowhere. So that is no association. All right. And I do believe that is all that we need for notes on this particular section. I am going to move on to page, so pause it if you need to, if you haven't finished writing. I am going to, let's see if I can get this really, there we go. Pause it if you need to. I'm going to, excuse me, move on to page 435, making a scatter plot. Okay, and I need to get more paper. Just a second. All right, so page 435. Recall that a set of bivariate data involves two variables, x and y, normally. Bivariate data can be used to explore the relationship between two variables. You can graph bivariate data on a scatter plot. A scatter plot is a graph with points plotted to show the relationship between two sets of data. The final question on a math test reads, how many hours did you spend studying for this test? The teacher records the number of hours each student studied and the grade the student received on the test. Actually, I'm going to switch how I'm doing this. Just a second. Okay, so letter A says, make a prediction about the relationship between the number of hours spent studying and test grades. Generally speaking, you would think, sorry, got to move stuff a little more. Okay, let's try this again. Make a prediction about the relationship between the number of hours spent studying and test grades. I don't know without looking at the data so much, but my guess would be the more time you spend studying, the higher your test grade will be. I would expect that that's pretty typical, that that's what'll end up happening. Make a scatter plot. Graph the hours spent studying as an independent variable and the test grades as a dependent variable. All right, so let's look at what we have got here. I'm going to be using little, maybe I'll use X's. This particular program doesn't have a whole lot of very good markers for it. I can do stars or hearts or X's. So I'm going to be doing X's. You will be doing dots, okay? The X will show up much better than the dot will on this particular thing. So let's look at this. Down here, I have hours spent studying. It goes from 0 to 1, and there's a blank in the middle of it. That means it's half an hour, okay? So that's half an hour, 1 hour, 1.5 hours, 2 hours, 2.5 hours, 3 hours, 3.5 hours, 4 hours, 4.5 hours, 5 hours. Going up, it starts at 50, and then it jumps to 60, but there's a line in between, which means we actually read this 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. All right? So I can tell right from here, nobody got below a 50 on their grade. The first person spent no time studying and got 75. So we go to the 0 studying and 75. Second person spent half an hour studying, 0.5, 5/10 of an hour studying, and got an 80. So at 5/10 of an hour, they got an 80. Third person spent 1 hour and got an 80. 1 hour, 80. Fourth person spent 1 hour, 85. 1 hour, 85. You note how these all seem to be lining up right on top of each other. That happens. Fifth person, 1.5 hours, 85. 1.5 hours, 85. Sixth person, 1.5 hours, 95. Still at the 1.5 hours, but now it's a 95. Third person, 2 hours, 90. 2 hours down there, 90 up there is the score. Fourth person, 3 hours, 100, all the way up to the 100. Fifth person, 4 hours, 90. So we go up to the 90. Okay. I know it's harder to tell with my X's, but the hours spent studying is along the bottom, so I just found that number, and then the test grade is along the side, so I went over and then up. Okay? What trend do you see in this data? You know why I did that? The trend that I see, okay. So the trend, what does it seem to be showing? It seems to be showing the more time spent studying, the better the grade was. Okay, that seems to be our trend, which is what we have predicted. Do you think the grade associated with studying for 10 hours would follow this trend? Given that studying for 1.5 hours got a 95, 2 hours got a 90, 3 hours got 100, 4 hours got a 90, I would actually say no, because 100 is the highest. 100 is the highest you can get, and those who studied 1.5 through 4 hours got very close, or even hit it. Which is why sometimes we talk about how, yes, you can study, 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 you can study. But if you studied for 10 hours and didn't get any sleep, you're probably not going to do very well on your test. There's only so much studying you can actually do. Okay, so I am going to pause it if you need to. I'm going to pause it so I can move on to the next page. All right, so now I am on page 436, interpreting clusters and outliers. A cluster is a set of closely grouped data. Data may cluster around a point or along a line. An outlier is a data point that is very different from the rest of the data in the set. A scientist gathers information about the eruptions of Old Faithful, a geyser in Yellowstone National Park. She uses the data to create a scatter plot. The data show the length of time between eruptions, which is the interval, and how long the eruptions last, which is the duration. Describe any clusters you see in the scatter plot. Well, there are actually 2 of them. There's one right there, and there's one right there. So let's see, what are our clusters? How can we describe that? There is one where it is between 40 and 60. I'm describing this smaller one down here. 40 and 60 minutes for about 2 minutes at a time. For 1.5, 2.5 minutes at a time. There is another where it is between 60 and 100 minutes, where it is 3 to 5 minutes at a time. And I am going to have to make this, if I make that larger, probably still gonna have to make this smaller. That's okay. What do the clusters tell you about eruptions of Old Faithful? It tells you the further apart the eruptions are, the longer the eruptions last. Okay? So this is how long they last. This is how far apart they are. So when it was 40 to 60 minutes apart, it only lasted for 1.5 to 2.5 minutes at a time. But when it's 60 to 100 minutes apart, it lasts for 3 to 5 minutes at a time. Describe any outliers you see. So let me draw. Okay, in my red. This point right here, which we didn't do anything. So the way that we describe this one is we say at, that looks like about 40 minutes. There was one that lasted for 4 minutes. And that's all that we can do to describe that. Suppose the geyser erupts for 2 2/10 minutes after a 75-minute interval. Would this point lie in one of the clusters? Would it be an outlier? All right, so let's go ahead and graph it. So at 75, which would be about right there, it lasts for 2.2, a little more than 2 minutes. So it's about right there. Is that in either one of the clusters? Would it lie in one of the clusters? No. It is too short of a duration for the length of the interval. See, it is very much not inside one of the clusters. It's very much outside. Suppose a geyser erupts after an 80-minute interval. Okay, I'm going to put a check on this one. Give a range of possible duration times at which point on the scatter plot would not be considered an outlier. So at 80, oh, actually, it doesn't want that at all. It wants us to do a line. So let's put this in green the whole way through. So starting at 80, going the whole way up. Where would it not be considered an outlier? It wouldn't be considered an outlier if it was between, look at where it lands on the 80, between the 3 and the 5. It would not be considered an outlier. If the duration was between 3 and 5 minutes, it would not be an outlier because that is when most of the most of that interval was. I don't know. That's a really bad sentence. Okay, so pause it if you need to. I'm moving on to the next page. Page 437, determining association. Association describes how sets of data are related. A positive association means both data sets increase together. A negative association means one data set increases and the other decreases. No association means there is no relationship between the two data sets. Data that shows a positive or a negative association and lies basically along a line exhibit a linear association. Data that shows a positive or negative association but does not lie basically along a line exhibits a non-linear association. I'm sorry, I didn't have us do the, so the linear association means it makes a line. Non-linear means it is positive or negative, but it doesn't make a line. Okay? So you need both of those. You need linear association, line. Non-linear, not a line. Okay? It should be pretty easy for you to keep it straight in your head, but add it to your notes anyway. Example 1, Susan asked 20 people if they would buy a new product she developed at each of several prices. This scatter plot shows how many of the 20 said yes at a given price. Describe the association between price and the number of buyers. So here we have a lower price. More people said that they would buy it. 20 people said they would buy it at $2. At $12, only 2 people said they would buy it. Okay, so each of these ticks goes up by 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Over here, same thing. 2, 4, 6, 8, 10, 12, 14. As the price increases, the number of buyers decreases, and so there is a negative association. Because the data points do not lie in a line, the association is non-linear. And the easy way to check that is to get your ruler out. And if I can try to connect those 2 dots, I end up with only those 2 dots being connected. Everything else is not connected. So what if? Based on the association shown in the scatter plot, what might happen if Susan increased to $14? If she decided to increase it again, she only has 2 people willing to pay $12. What might happen if she increased it to $14? Well, I think no one would be willing to buy it. I mean, I suppose there's somebody who's like a collector, if it's a collector's item, or maybe one of her parents or something like that would sit there and feel sorry for her and buy it, but no stranger's gonna buy it. This plot down here, down at your turn, shows the reading level and height for 16 students in a district. Describe the association and give a possible reason for it. So people who are taller have a higher reading level. That's what this is showing. Okay, so we're supposed to describe the association, which is literally what I just said. People, oops, whoa. People who are taller have a higher reading level, which is absolutely insane until you think, who are the short people at our school? Shortest people at our school, who are they? The itty bitties. So we go all the way down to our little TKers and kindergartners, and they're so cute, but they're tiny. Those are the shortest people in our school. So people who are taller have a higher reading level. Why? The people who are shorter tend to be younger. Sorry. And that's really all there is to it. It's kind of a trick question, almost. Okay, so I'm pausing there, moving on to the next page. And we are now on the guided practice. I think I'm going to try doing the X's and see if we can't get our graph to go with that one, because number 1 says we need to make a scatter plot of Bob's data. Bob recorded his height at different ages. This table shows his data. So when he was 6 years old, so there's the 6, he was 45 inches high. So we go up to the 40, and then we realize, oh wait, we're going by 5s here. 40, 45, 50, 55, 60, 65, 70. So we go up to the next line, there is 6, and it is now 45. Second one, it says that he is 8 years old. He was 50 inches. So I go over to the 8 years old, and then I go up to the 50 inches and put another mark. At 10 years old, he was 55 inches. I go over to the 10, I go up to the 55, which is between the 50 and the 60, and put another mark. At 12 years old, he is 61 inches. So I go over to the 12, up to the 60, and then a teeny bit above it to 61. And at 14, he is 63 inches. So I go over to the 14, up to the 60, and then a teeniest bit more, 63. So right there like that. Describe the association between Bob's age and his height. Explain the association. So it is a positive or negative? Is it going higher, positive, or lower? Negative. Positive. It is a positive association. Association. As he gets older, he gets taller. There you go. This scatter plot shows the basketball team shooting results for 14 players. Describe any clusters you can see in the scatter plot and identify any outliers. So clusters we got going on. We have this right there, that's a cluster. And that's really the only place where they're all right on top of each other. Here we have a trend. We have something that's going gradually in the same direction, but it's not really a cluster. They're not all right on top of each other. So describe any clusters. Between 15 and 25, because that looks like it's by 5s. 5, 0, 5, 10, 15, 20, 25, 30, 35. So between 15 and 25 attempts, oh, sorry. Okay. Between 15 and 25 attempts, 10 to 15 baskets were made. Is a cluster. Oops, I was probably supposed to put that first. And then our outlier, because we do have an outlier, is right over here. He did 35 attempts and made like 5, 10, 15, 20, made like 18 of them. The outlier is one player made 35 attempts and like 18 baskets, and 18 baskets were made. Explain how you can make a scatter plot from a set of bivariate data. Okay, I can collect information in two sets that are dependent on each other. I can then plot these as points on a graph and look for outlier and look for, clusters and outliers. The reason why I say right here, it has to be two that are dependent upon each other, is because if one of my data points is what day of the year it is, and my other data point is how many times I popped my bubble gum, unless we're trying to decide which day I pop my bubble gum the most on, it's not going to be relevant, or unless you're doing an experiment about how many times can you pop bubble gum depending on what the temperature is. But see, then you would be doing it based upon temperature, not based upon what day. Any event, so all that is left for you to do is the independent practice. Good luck. Talk to you later.